A line has its NDA 10 mm above HP and 15 mm in front of VP. The NB is 55 mm above HP and the line is inclined at 30 degrees to HP. The distance between the end projectors is 50 mm. Draw the projections of the line. Determine the true length and its inclination with VP. So that means he has given the true length and its inclination with respect to the VP. That is 5. We need to find out. So here a line has its NDA 10 mm above HP. So when you look from the front view, you can see the distance 10 mm above HP. When that is projected, it will be seen on the vertical plane, so which is 10 mm above HP. And 15 mm in front of VP. In front of VP will be seen in the horizontal plane. So when you look from the top view, we can see the distance in front of VP. So that distance, when it is projected, it will go and falls on HP. So you mark that point as small a. And this as A dash. Then the NP is 55 mm above HP. So when you look from the front view, we can see the distance NB, which is 55 mm above HP. And that image, which you can see on the vertical plane, and that you will going to get the locus of B in the front view. And the line is inclined at 30 degrees to HP. So we have the true inclination of the line, which is inclined at 30 degrees to HP. So from here, you measure an angle of 30 degrees and then draw a line such that it will going to cut the locus of B in the front view, because he says the line is inclined at 30 degrees to HP. So that means it is the true inclination of the line. So this will going to be theta. When you look from the front view, that image will going to falls on the vertical plane. So once it cuts the locus of B in the front view, so now we got the true length. Once you get the true length in the front view, now the distance between the end projectors is 50 mm. So here the distance between the end projectors, that means from the projector A, you measure a distance of 50 mm and draw a vertical line, vertical projector, so that it will going to cut the locus of B in the front view. So it becomes B dash. Then join A dash B dash with a dark line. Now we know that the distance between the end projector, once we know the distance between the end projectors in the front view, which cuts the locus of B. Now our main aim is to find out the locus of B in the top view. So to do that, we have to take the true length in the front view. We know that the true length in the front view is this, which is AB1, which is 15 mm in front of VP, that is A, and B1 is also 15 mm in front of VP. So this is the true length in the front view, because the line is parallel to VP. Now when you take the top view of this, the top view of this will going to lie is also AB1, which is 15 mm in front of VP. So here, as we know that the distance between the end projectors line should be lie on the same line, that is the front view is here, so the top view must also lie on the same end projector. So with a capital A as center, you're taking the radius of AB1 when it is rotated such that in the line in space, so that the B will lie on this end projector line, so that you will going to get this point B. So when it was in space, it will going to be rotated like this, but when it is on the image, so that image with AB1, with A as center, AB1 as the radius, when it is rotated, that will going to cut the point B on this end projector line, which is 50 mm here, and also the end projector in the top view is also 50 mm. So the top view point will going to lie on this end projector. So you're going to get this point B. Then join A to B with a dark line. So you will going to get this as the locus of B in the top view. So that in space you will going to get this point, which is B, and when it is projected you can see that B dash also here. So this is capital A and capital B. So now we have, this is the line which is in space. Now we got the top view and we have the front view. Now we need to find out the true length, the horizontal plane. So we know that the line which is in space, which is capital AB, when it is rotated and make it parallel to HP. So that means A is above HP by 10 mm and this B2 should also be above HP by 10 mm. So then the line will be parallel to HP. When you look from the front view, that image will going to be on A dash, B2 dash, which is above HP by 10 mm here. B2 dash is also above HP by 10 mm. So now the line is parallel to HP. Now, when you rotate this, when it is made parallel to HP, so when you look from the top view, you will going to get the true length in the horizontal plane, which will going to be AB2. How we will be able to find that true length? So here, you made the line parallel to HP. Once you make the parallel to HP, its true length will be seen in the horizontal plane. When you project that, it will going to cut the locus of B in the front view, in the top view. So you're going to get small AB2. So this is the line which is going to be the true inclination with respect to VP, which is fine. So this is how you will be able to. So when you are rotating this, with respect to A and make it AB2 parallel to HP, so the image will going to be rotated from here to here. So this is how you will be able to analyze this problem in 3 dimensions. Now we will going to take up in the individual A. That is, in the first case, what we have done is, so here first the end A, which is above HP and in front of VP, and also we know the distance above HP is seen, which is 55 mm, which is already given. So when it is given, you're going to get the locus of B in the front view. So now we know the true inclination with respect to HP, which is given, which is the true length line, which is 30 degrees. So when it is with A center, when it is drawn a line, so that the boundary will not going to extend this locus of B. So in space, so we're going to get AB1. So when it is projected, it will be on the locus of B at this point. So that you will going to be able to find out the true length. Once you find out the true length, now I need to write the top view. So with A as center, when you rotate this AB1 line such that it will going to, that image will going to lie on this end projector, which is the distance between the end projectors is 50 mm, which is given in the front view. As it have the locus in the front view, it will go to cuts here. So you get the front view here. And then this is rotated till this projector line, this arc will going to be falls on this end projector line, so that you will going to get this point B. Then you will going to join the locus, then you are going to draw the locus of B and join A to B. So that is what we have shown in the orthographic view in the stepwise. First you have taken 10 mm and 15 mm, and then you got this point. Then we know the distance above HP, you draw the line and you write the locus of B and take the true inclination line, which is 30 degrees, which is given. So when it has been drawn, so it will going to cut the locus of B here. So we're going to get B1 dash. Now we need to write the top view. So draw a vertical projector from here, so that it will going to, it is parallel to VP, that is AB1. So that AB1 is rotated and made it on this line. So when you draw a horizontal vertical projector from here, so because the distance between the end projectors is known, so the top view point which was here should be lying on this plane or this line. With A as center, you rotate that B1 so that it will going to ends on, which will going to cuts on the end projector line. So this is B dash and B. So now we got the locus of B in the top view. Now similarly, if you want to find out the true length in HP, so we have to make the line parallel to HP. So that means we are rotating this line which is in space parallel to HP. So since it is parallel to HP, so we are getting the true length in HP. So that is what we have done. Here, when we rotate this and make that line parallel to HP, that is the front view line is made parallel to HP, then you are going to get A dash, B2 dash is the line which is parallel to HP, which is 10 mm above HP. When it is projected, that will going to fall on the locus of B in the top view. Then join AB2. So here, since this line is parallel to HP, so you are getting the true line, which is small a and capital A and capital B in bracket. So this is how you will be able to analyze the 3D and also in the orthographic view in the stepwise. Now we will going to solve this problem using the sketchbook. So first we will going to draw the XY line and mark X and Y and VP above XY line. and HP below XY line. He says NDA is above HP by 10 mm and 15 mm in front of VP. So above HP is seen in the vertical plane. So on the XY line you measure 10 mm and draw a horizontal line. Similarly 15 mm in front of VP. In front of VP will be seen in the horizontal plane. So that is below XY line. From XY line you measure 15 mm and draw a horizontal line. Both should be a thin line. Consider any point on this line and draw a vertical projector so that it will go into cut A dash here and A here. Then the NP is 55 mm above HP. So from XY line, you measure 55 mm and draw a horizontal dash dot line. So now we have the locus of B here. So you write this as the locus of B. Then he has given the true inclination with respect to HP. That inclination can be seen in VP. How do I know that it is the true inclination? Because he says the line is inclined at 30 degrees to HP. Since it is a line, it should be true length line. So from A dash, by using the protractor, you measure an angle of 30 degrees with respect to the horizontal and then draw an inclined line such that it will go into cut the locus of B here. And you mark this point as A dash and you mark this point as B1 dash and join this A dash B1 dash with little bit thicker than the XY line. So you have got B1 dash. So since it's a true inclination line, so you have capital A in bracket and capital B in bracket. Now as we know that the distance between the end projectors is 50 mm, we know that we have one end projector which is A, and from here you measure the distance of 50 mm and draw a vertical projector so that it will go both in the front view and as well as in the top view. So it will go into cut the locus of B in the front view because we have the locus here. But in the top view, we don't have a locus. So it will extend directly below the XY line. Then we know that this is the true length line in the front view. So its corresponding top view should be parallel to XY. So when that rule is applied, so A is in front of VP by 15 mm. So B1 dash should also be in front of VP by 15 mm. So the top view of B1 dash should be B1. So draw a vertical projector from B1 dash such that both AB1 will be in front of VP by 15 mm. So now we got the top view here. But actually we have the front view point is here, that is B dash. The top view point should, the end point of the top view B should lie on this vertical projector. So with A as center, by using the compass, you measure the distance of AB1 and then draw a smooth arc such that it will go into cut this end projector at this point. So since this is the front view point as B dash and now this point will going to be the top view point B, then join A to B with a dark line. So once you get this, now we got the locus of B in the top view also. So draw a dash dot line here and then write locus of B in the top view. So locus of B. Now once you get the locus of B, then we need to find out the true length in HP. So you have to make the line parallel to HP, which is the line which has to be made parallel to HP, the line which is inclined to HP. So the front view line of the line should be made parallel to HP. So here it is, we know this is the front view because its top view is also inclined. So you make that line A dash B dash should be parallel to HP. With A dash as center, by taking the radius of A dash B dash, by using the compass, draw a smooth arc so that it will go into that B2 dash is also above HP by 10 mm. So A dash B2 dash is the line which is above HP by 10 mm. So then, since it is parallel to HP, so you are getting the true length in HP. So draw a vertical projector from B2 dash to the top view so that it will go into cut the locus of B in the top view here. Then mark this point as B2. As we see here, A dash B2 dash is the line which is the front view line which is parallel to XY. Its corresponding top view will be in true length. So you mark it as capital A in bracket and capital B in bracket and then join A to B2. Then join A and B2 with little bit thicker than the XY line. So as we see the true length and its inclination with VP. So since we is asked to find out the true length, so you show the dimension of true length here by using the compass or by using the scale. You measure the distance from A dash B1 dash or A to B2. Then the true length line will be 90 mm. And by using the protractor with reference to the center point A with respect to the horizontal AB1, you measure an angle of phi, which is the true inclination with respect to VP. So which will be 42 degrees when you are doing it in manual. When you are doing it in computer, true length will be 90.00, phi will be equal to 41.63 degrees. So this is how we will be able to solve the problem in the sketchbook.